All right, let's talk about this a little bit. Man, I coughed right beforehand. I thought it was out of my system. A worker earned a 2% increase in her annual salary for each of 4 years. She plans to continue working in her position for an additional N years. If she continues to earn a 2% increase in her annual salary, which statement describes the expression that can be used to calculate the total percent increase in her annual salary from the first year to the last year? So when I look at this, I have to kind of understand which one is which. So a worker earned a 2% increase in her annual salary for each of 4 years. So she started off at 1, right? 1 times her salary. 1 times her salary, basically. So she started off at her salary. And then so at first she's just earning, the first year she's just earning her salary times 1. The second year, she's earning her salary times 1 plus an additional 1%. So 1 plus 0.02. Remember that is 2% plus an additional 2% is what I meant to say. And then the next year, she'll have 1.02 plus, at times that, what it was, her new salary will be 1.02. And then the next year, her new salary will be 1.02 times that 1.02, and it'll keep going over and over again. So every year, this salary, her current salary before the raise will be 1.02 times the next year, times the next year, times the next year. And there's a much easier way of writing this, and that ends up becoming 1.02 to the N with how many years she's getting that salary. And what's interesting about this is that, so at first we have the 1.02, and she got it for 4 years. She got that 2% increase in her annual salary for 4 years. That, you might be wondering where this number is coming from, and that is what's happening. It's because it's exponential. It keeps increasing exponentially. Now, it says, so we've got that part, so we can discount this right here, okay? If she continues to earn a 2% increase in her annual salary, which statement best describes how to figure it out from the first year to the last year? So we don't know how many years she's going to work, okay? So what we end up doing is that we have this part for the first 4 years, and then this would keep going. This N right here would keep going forever. But we already know what it is now. We want to know how long it is and how much it'll be in 10 years' time or 20 years' time. So it's like if I continue working 20 years, I'll have this much. If I keep, and then my N will be replaced. So it'll be 1.02 to this N right there. Now, again, this might seem a little confusing, but if you have her salary. So her salary is something, right? And what we're going to multiply our salary by every year. So after 1 year, we're going to multiply it by 1.02. This is after 1 year. The next year, we're going to multiply that salary, because that'll be her new salary, by 1.02. This is year 2. Notice this is just 1.02 squared. So on year 2, it's like that. On year 1, it was like that. And then notice every year we're going to keep multiplying by that increase. 1.02 is a 2% increase. That 0.02, it means 2%. And this is your starting salary, always there. And so this is the third year. And that's where we're getting that to the 4. Now, if she knew that she was going to get a salary increase of 2% from the very first year, and she wanted to calculate it from there, then she'd be able to just do 1.02 to the N and then count. But she's not there. She's in her 4th year. She's trying to figure out how much she needs to, how much she's going to get in 20, 25 years, 30 years. So she's starting right here. And she didn't give us a lot of information. So she's just not super nice, apparently. But she could have just looked at her bank statements and said 1.02 to the 4. I don't need to write that. I could just write what my salary is and then just keep multiplying that by 1.02 to whatever, how many ever years. But that's not the kind of problem we have right now. But this will be what it is right here. This is the first 4 years of increases. So her salary is technically like that. We don't know what her salary is. But this part right here is how much is going to increase. And that's what she wants to know. So in this case right here, one exponent property. This question is just hiding exponent properties in a word problem. It's basically saying when you have two things with the same base and you multiply them together, what do you do with their exponents? Well, you add them. That is the property right there. So this is the only answer it can be. This is not true because that's adding that little bit, and we're not looking for that. We're taking her salary or multiplying it by 1.02 a certain number of times to figure out how many years will go by, because it's an annual salary increase. Two real numbers are defined as, well, why does it say defines as? I didn't write this test. This was the state that did that. We have A is equal to that stuff, which is a repeating decimal. It's for repeating. Repeating decimals are always rational numbers because we can always find a pattern and then be able to use some of our little algebra tricks to reduce it to a fraction. And what's really cool about this is that on your Desmos calculator, if you input that 0.4 repeating, it will tell you what the fraction is. And it is like 4/9 or something like that. But then this B is equal to this stuff. Basically, if you're looking at these things and you're trying to figure out if they're rational or irrational, you're just looking for a pattern. The pattern here is that 4 is repeating over and over again. The pattern here is that, hey, look at that, there's no pattern. We got 3, 5, 4, and a lot of times students will say, oh, it's 3, 5, 4 repeating. No, 3, 5, 5, which is not the same number. We don't want just one number repeating. We need a steady pattern with no differences. These little numbers after decimal matter. So it doesn't look like they repeat exactly. There's no pattern. It goes 3 and then 5 and then 4 and then 3 and then 5 and then 5 and then 4 and then 3 and then 5 and then 5 and then 5 and then there's no real pattern here. So this is an irrational number. Now, one thing that you could do, and remember, if you multiply two numbers that are, one of them's rational and one of them's irrational, your final answer will be irrational. And my reasoning for this is different than the reasoning that the video that I'm going to send out talks about, which I haven't gone through the whole thing, but I know that they talk about just putting it into the calculator and seeing and then explaining that, which you could totally do. You can put this into the calculator, multiply them, and see that it's irrational. Or you can say that it is irrational because multiplying a rational number times an irrational number gives you an irrational number. There is no way to multiply a rational number by an irrational number and for it to be rational. Things like that. There are so many ways that you can describe it, but you want to explain it and not to waste a lot of time. You need to write more than this, but rational times irrational equals irrational. Another way to do it, again, though, is to plug them both into exactly as they are into a calculator, multiply them, and see that it is irrational, and say that the digits after the decimal point do not repeat in the product. Therefore, it is there's no pattern there. It cannot be written as a ratio of two numbers. There's a lot of different ways to write that. Now I'm going to stop right here and then come back to this one to make sure that we don't lose any of our progress on our videos.